seasonal indices. So in the previous videos, we were looking all about smoothing, so where we can get rid of fluctuations by doing the mean or the median for various points. Well, this is not terribly effective when the data is occurring in a seasonal fashion, because essentially you're just squashing down the data and you can still see the seasons. So sometimes we want to know if there's an actual trend going on, even without, if we could eliminate all the seasons, because sometimes that can make it really difficult to see whether or not there is a trend. So we know that smoothing data is not very good with dealing with seasonal data. So to reveal underlying trends of the seasonal data, what we do is we do a process called deseasonalizing. Now, I know that sounds a bit like something they might use on MasterChef. You need to deseasonalize the roast steaks to bring out the flavor. So what we do to do this is that we calculate the seasonal indices. So seasonal indices are calculated so that their average is 1 and that the sum of the seasonal indices is equal to the number of seasons. So what does that mean? I should say 1. So what that means is that essentially, for each season that you might have, so for instance, if it's for a year, let's just take the normal weather seasons, so summer, winter, spring and autumn. So basically what you're doing is you're calculating the average, let's say, sales that occur in each of those, and then basically we take the average throughout the year. We do an average of those seasons, and essentially a seasonal index will determine per month of that season whether or not your sales are a wee bit higher or a wee bit lower than the average. So, and when we add everything all together, they should equal the number of seasons that you have. So, for example, the sum of the seasonal indices, if I'm dealing with daily figures for data from Monday to Sunday, well, that's going to be, there's 7 seasons there, because each day would be part of, over this week, this cycle, and that the sum of the seasonal indices will be 7. The daily figures for data, if I'm doing Monday to Friday, well, that's going to be 5. The cycle will be the week. So remember, a cycle is the pattern which is greater than a set of seasons. Monthly figures, well, that's when we start dealing with years. So monthly figures, the number of seasons in a year will be 12. If we're dealing with quarterly accounts, then that's going to be 4. So essentially what a seasonal index will tell us is that for a particular season, so for a particular season, we're going to see how that compares to the average season. As an example, let's just say we did some seasonal, I was telling you about some seasonal indices, and I wanted you to interpret them. So the best way, the easiest way to do that is to turn them into some sort of percentage. So what I'm talking about there is, let's just we'll look at employment figures, and they might have that the seasonal index for unemployment for February is 1.2. And what does that mean? Well, if I turn that into a percentage, what that means by timesing it by 100%, what that will mean is that it's telling me that it's 20% higher than the average. So the average unemployment, we shrink that down to the number 1. And then what we're doing is we're measuring to see how each month fares to that average. So for example, if you find that August will say 0.9, if we times that by 100, what that's telling me is that, or which would be 90%, that would be telling me that August is 10% lower than the monthly average. So to deseasonalize data, what we just need to do is we need to take your actual figure and divide it by a seasonal index. To reseasonalize it, what we just need to do is to take the deseasonalized figure and multiply it by the seasonal index. So that will get us the actual. So in case we're wanting to know here, so this will get the actual here. So that's the actual there, whereas this will get me my deseasonalized. The seasonal index SI for cold drink sales for summer is equal to 1.33. Last summer, Beach's kiosks actual cold drink sales totaled $15,653. What were the Deseasonalise sales? So what the hell is this even asking? Well, what it's asking is saying, all right, if we know that cold drink sales will be affected by the time of the year, we probably will sell less in cold seasons than we would in warm seasons. So we're wanting to know, if I eliminated the fact that we change over time, what would be the sales? So I know from my formula, Deseasonalise is equal to actual figure divided by seasonal index. So the deseasonalized is equal to, this is the actual, as it says here, and this is the seasonal index. So we will do 15,653 divided by 1.33, and this will give us 11,769. So this tells me what this means in reality is that this would be the figure if there was no such thing as summer, winter, autumn, spring, based on all the averages. This is really how much money I'm making. The seasonal index for cold drink sales for spring is 0.85. Last spring, a Beach's kiosks deseasonalized cold drink sales totaled $10,870. What were the actual sales? Using our formula from earlier, actual is equal to deseasonalized times seasonal index. So actual is equal to, so this is our deseasonalized figure, and this is the index. So 10,870 times by 0.85, and this will be equal to $9,239.50, or $9,239.50. So what does this mean in reality? Well, this means that, okay, in spring, we are what's happening is that we're probably getting slightly less cold drink sales than normal, but we're going to adjust the sales to get rid of the seasons. So when we deseasonalize it, we just average it to make it a little bit higher, but in reality it is actually a little bit less. Exercise 6D.2. The following table shows the quarterly seasonal indices for revenue to a publishing company from the sales of maths textbooks. 1, 2, 3, 4. We've got 4 quarters there, and we're calculating the seasonal indices. What is the missing quarter 2 seasonal index? Well, these all have to add up to 4. So these all have to add up 4 because that's the total number of seasons. We've got 4 quarters, there are 4 seasons in the year. So to get that missing figure, I'll need to do 4, take away 1.9, take away 0.6, take away 0.7. And so that will equal to 0.8. Part B, to correct for seasonality, by what percentage should the sales for quarter 2 be increased? Now, we don't have any sales for this one, so how on earth can we answer this question? Well, first and foremost, if we're unsure, let's see what we're supposed to do. So, deseasonalized is equal to actual figure divided by seasonal index. So to correct for seasonality, that phrase means I have to deseasonalize. So I have to use this formula somehow. Is equal to actual divided by index. So I can already fill in part of it, which is 0.8, because that's the figure, the seasonal index for the second quarter. But what do I put in the top? By what percentage should the sales for quarter 2 be increased? The sales plural, so that would mean we need to refer to all of them. Well, when they calculated all of this, they would have taken all of the sales and found the average. And what is the average sales? Well, when you're making the seasonal index, the average is, so this is all, so therefore we need to look at the average. And the average for seasonal indices is always going to be equal to 1 because the average seasonal index for each one should be 1. So 1 divided by 0.8. So when you don't know, this is what we need to do. So to correct by what should all of the sales for quarter 2 be increased by? So 1 divided by 0.8 is equal to 1.25. It says by what percentage? So then I just have to take 1.25 times by 100, and that equals to 125%. Common trap and mistake is that people will look at the seasonal index and say, oh, it's 0.8, that's 20% below the average, so therefore I need to go and increase it by 20%. No, because that's not compensated, that will not change. You're just plonking on a random 20% of what? No, you need to you need to get 1 divided by 0.8, gets you that 1.25, and then you multiply whatever those figures are by 125% or times it by 1.25. This is a very common exam question. Everyone in the state falls over it because they don't quite get it. If you're not sure, that's fine. Just look for these examples and just keep trying and trying and trying. The company predicts that its deseasonalized quarterly sales will be $1 million for each quarter. Based on this, what would you predict the actual sales for quarter 2 to be? So we have to use our previous bits of information here. We better use a formula. So we're asking to find the actual sales. Actual equals deseasonalized times seasonal index. So actual, it predicts that the deseasonalized is going to be equal to $1 million. So we're going to do 1 million times by the seasonal index, so for quarter 2, which was 0.8. And so when you put that together, it'll be, so we're predicting that the actual values will be 800,000.